Having trouble determining the real serial number from your SSD? In this video, we will look at obtaining the serial number for the Samsung portable SSD T7, a Western Digital SATA SSD in an M.2 enclosure, and then also a Western Digital NVMe SSD in an M.2 enclosure. Please help me out by hitting the subscribe button so I can see the heaven in your eyes. The first SSD we are looking at in this video is the Samsung T7 portable SSD. In Windows, let's look at the registry by typing regedit in a command window. And then in the system hive, under control set 1, enum, and then SCSI. Note that it's not USB store that we're looking at because these SSDs adhere to the SCSI protocol, so they're not USB devices. So when I expand the Samsung Prod P SSD T7, we see the serial number as being 6*328D34C5 0*00000. And this is a unique identifier that Windows has assigned to this device, but not the serial number that we are expecting. Next, let's take a look at the Diagnostics event log by launching the event viewer. And then we look under Microsoft, Windows, Partition, and at the Diagnostic.evtx file. And then once we found the right entry in the log, we will go ahead and click on the Details tab and then see that the serial number here is reported as X4357006R0SN3T5S. As you can see here, the serial number is actually reported in reverse, which is obviously different than the one that's in the registry. But then if you look a couple lines down here at the parent ID field, we see MSFT30 S5T3NS0R607534X, which, if you take away the leading MSFT30, is the serial number printed on the device. The third method that we're going to use, we're going to go ahead and launch the command window. And then here we can go ahead and type WMIC, which is the Windows Management Instrumental command line. And we're going to type the command that's going to get us information for the disk drive. In particular, we are looking for the model name, the serial number, and the device ID so that we know we're looking at the right disk. So I'm going to type WMIC disk drive get model, comma, serial number, comma, PNP device ID. So this method, when it comes back, gives us the reversed serial number, just like in the events log. Lastly, let's launch a PowerShell window. Then we're going to use the get disk commandlet to get the information for the disks that are visible in the operating system. And in particular, we are interested in the disk number and the serial number of the disk. So I'm going to go ahead and type get-disk and pipe that to select disk number, comma, serial number. And once again, we get the reverse of the printed serial number. So let's go ahead and take a look at what Linux gets us. All right, so we're booted into the Kane Linux distro, and then I'm going to bring up a terminal window. And then I'm going to use the lsusb command. And what we see here is the bus and device numbers for all of the things that are on the USB bus, and we're interested in the bus and device number 2 and 4. So let's go ahead and put that into the lsusb command by doing sudo lsusb-v for verbose, and then -s for a specific device. And that device is 2:4, and then pipe that through less. And what we get back is the serial number of S5T3NS0R607534X. So next, let's go ahead and use dmessage to see what the system saw as the serial number. So I'm going to go ahead and do dmessage, pipe that to tail, -15 to look at the last 15 lines. And once again, we see the same serial number of S5T3NS0R607534X. Next, because we're looking at a hard drive, let's use the HDPARM tool to view the information on that drive. I'm going to go ahead and do sudo hdparm-I/dev/sdb and pipe that to less. And we get nothing here of use because we are operating on a device that adheres to the SCSI protocol and not the IDE or SATA protocol. So we're going to have to use the sdparm command. So we're going to do sudo sdparm-page-sn/dev/sdb. The --page option allows us to specify what information we want returned, and then SN stands for serial number. So what we get back is the serial number of X435706R0SN3T4S, which is the reverse of the actual serial number. All right, let's take a look at the last tool we're going to use, which is Smart Controller. I'm going to do sudo smartcontroller-a /dev/sdb and pipe that to less. And we're greeted with an error that says it encountered an unknown USB bridge and wants us to specify a device type with the -d option. So we're going to go ahead and do Smart Controller again, and this time we're going to add the -d option and then specify a SCSI drive because this is adhering to the SCSI protocol. And this time we are greeted with a serial number of X435706R0SN3T4S, which is again the reverse of the actual serial number. So the conclusion here is that LSUSB and dmessage are returning the correct serial number. HDPARM doesn't work properly on this device as it's classified as a SCSI device as opposed to a SATA device, so we had to use SDPARM. And then once we realize that this device is treated as a SCSI device, using SDPARM and Smart Controller with the SCSI option returns the reverse of the actual serial number. The next device we're going to look at is a SATA SSD in the M.2 form factor. We're going to be putting the SSD into an enclosure and then connect it to our exam workstation via USB. So in Windows, let's take a look at the registry in the system hive under control set 1/enum/SCSI. Again, because these drives adhere to the SCSI protocols as opposed to the USB protocol. And when I expand the WDC, WDS100T2, blah, 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 we see the serial number listed as 7%FD96. E82 ampersand, etc. This is the unique identifier that Windows has assigned to this device, but not the serial number that we are expecting. So next, let's take a look at the diagnostic event log. I'm going to go ahead and do a refresh to get the new log entries. And then once we found the right entry in the log, we see the serial number here reported as CB90429000290. And that's going to be different than what's in the registry. And at this point, I am not sure what this is a serial number of. Next, let's take a look at our DOS command window. We're going to use the WMIC command again to get the information for the drives. So I'm going to go ahead and just up arrow. And this method also gives us the backward serial number of CB90429000290. Lastly, let's launch a PowerShell window. And we're going to use the get disk commandlet to get the information from the disks visible to the operating system. And once again, we get the backward serial number of CB90429000290. And again, this is not the serial number that is printed on the drive, so it's unclear what this is a serial number of. But let's take a look at what Linux gets us. Using the LSUSB command to look for the SATA SSD, We see that the bus and device numbers of interest is 2:4. So let's put that into the lsusb command by doing sudo lsusb-v-s 2:4 and pipe that to less. And here we see the serial number of 09200924009BC. And even though this looks like a serial number, this is not the number printed on the drive itself. So it's a mystery of what this is, and it is reverse of what we got from Windows. Next, let's use dmessage to see what the system saw as the serial number. I'm going to do dmessage, pipe that to tail-20. And we see the same number of 09200924009BC. And now, because we're looking at a hard drive, let's use the HDPARM tool to see what information that drive gives us. So I'm going to do sudo HDPARM-I/dev/SDB and pipe that to less. Now we see the serial number of 21153S801908, which is what's printed on the drive. So that's great. And if we run SDPARM to try to get the serial number by doing sudo SDPARM-page equals SN/dev/SDB, we get CB90429000290. which again is the reverse of the serial number that was given to us by lsusb and dmessage. Let's take a look at how Smart Controller reports back by doing sudo smartcontroller-i/dev/sdb. And this time we're greeted with the serial number of 21153S801908, which is the one etched onto the drive. So that's great. And just for experimentation, I'm going to go ahead and use Smart Controller again, but this time I'm going to add the -d SCSI option so that it looks at it from a SCSI protocol. And we are greeted with the serial number of CB90429000290, which again is consistent with the reporting from SDPARM, and then the same as the numbers reported by the Windows tools. So is this the serial number of the adapter or enclosure instead of the actual SSD? Or is there a different serial number depending on what protocol you are addressing the device? I don't know, but let's move on. The last device we're going to look at is a NVMe SSD, and it's also in the M.2 form factor. And I'm going to be putting that SSD into an enclosure and then connect it to our examination workstation via a USB 3 cable. So Windows, again, let's look at the registry and the system hive under Control Set 1, enum SCSI. And this particular device identifies itself as a Realtek product, RTL9210. So when I expand that column here, we see the serial number listed as 7&34BE5A1 etc. And once again, this is a unique identifier that Windows has assigned to this device, but not the real serial number that we are expecting. So let's look at the diagnostic event log. And then we're going to do a refresh to get the new events. And then once we found the right entry in the log, we are going to click on the Details tab, and then we see that the serial number here is reported as a whole bunch of zeros, which is definitely not right. But then if we look a little bit further down in the parent ID field, we see MSFT 300 123 456 79907. So this looks more like a unique serial number. Let's keep that in mind and move on to the third method, which is looking at the command window. And then we're going to type the WMIC command to get the information from the drive. And this method also gives us the incorrect serial number of all zeros. Lastly, let's launch a PowerShell window. And we're going to go ahead and again use the getDisk commandlet. And once again, we get a whole bunch of zeros, which is definitely not the right answer. Even though the tools consistently give us all zeros, I still insist that is a horrible serial number. Let's take a look at what Linux gets us. All right, so in Linux, I'm going to use the lsusb command. We're going to see that the bus and device numbers are 2 and 5. So putting that into the lsusb command, we get sudo lsusb-v-s2:5, pipe that into less. And here we see the serial number of 012345679907 from this Realtek device, which again looks like a legit serial number of some sort, but probably not for our actual SSD. Let's see what the other tools give us. Using dmessage, piped it to tail-15, we see the same serial number of 012345679907. Let's take a look at sdparm, sudo hdparm-I/dev-sdb, pipe it to less. And now we see the serial number of 21234S801548, which is what's printed on the drive. All right, finally we get a tool that gives us something good. Now, even though hdparm gave us the right serial number, let's take a look at what sdparm command gives us. So if we do sudo sdparm-page equals sn/dev/sdb, we get a whole bunch of zeros again, which is not a good serial number. Let's see what smart controller gives us with sudo smartcontroller-i/dev-sdb. It comes back with an unknown USB bridge error. So let's do it again with sudo smartcontroller-i-d-sat/dev/sdb. And this time we're greeted with a serial number of 21234S801548. And again, it's the one that's etched into the drive, so we are able to get the proper serial number. So what do we have? Looks like another round of inconsistencies. On the Windows front, the registry seems to be tracking the device, but not the serial number. The other three tools are pretty consistent in terms of either getting the serial number or the enclosure or all zeros. So unfortunately, I would rate Windows poorly for its ability to obtain the serial number of any of these devices. On the Linux front, lsusb and dmessage will properly report info for the Samsung T7, but then reverse the serial number when we used hdparm and smart controller. For the M.2 enclosures, lsusb and dmessage got some variant of the enclosure's serial number, while hdparm, sdparm, and smart controller got the correct serial number. So once again, whatever your OS choice, be aware of these differences in behavior with the different devices when you use these tools, and be careful what you write in your forensic reports as the serial number. Going back to Windows, I'm going to use a few other tools to look at the drives. The first tool is the device manager that comes with Windows, and you can launch it by right-clicking on the Windows icon on the bottom left of your desktop. And then once it's launched, go ahead and expand the disk drive category. Find your drive in question and then right-click to get the menu, and then select Properties. Once the pop-up panel appears, click on the Details tab, and then look for the property name Parent. And in this case, it reported the serial number as MSFT30S5T3N S0R607534X. And so it basically reported the serial number prepended with the MSFT30. Next, I'm going to launch the Wiebetech Write-Blocking Validation utility, which you can download for free from Wiebetech. And you can get the link from the description below. And you can rescan if you just added a device, and then click on the drop-down to select the device you're interested in. Here, I'm looking at disk 2. So once selected, you will see the serial number field populated on the left. And so for the Samsung T7, it is reporting MSFT30 S5T 3NS 0R6 07534X. And so this again is the serial number prepended with MSFT30. The last tool I'm going to use is FTK Imager from AccessData. And it's free to download. And you can go ahead and see the download link in the description below. Once launched, I'm going to add a source of a physical drive. Then select drive 2 in my case. And then you will see the properties window pane, which lists out the drive serial number as X4357006R0SN3T5S. And essentially this is the serial number in reverse. So all these tools, all three of these tools are able to obtain a variant of the real serial number for the Samsung T7. Let's see how they do for the M.2 enclosures. So if we run the device manager on the SATA SSD, we get MSFT30092009240BC. So in this case, looks like the device manager only sees the enclosure's serial number and not the actual device itself. If we look at the Wiebetech Writeblock validation utility by doing a refresh, we can see that it reports 21153S801908. So the Wiebetech utility properly picked out the correct serial number. And lastly, if we run FTK Imager and load in this particular drive, the serial number is reported as CB90429000290. So it looks like it picked out the reverse of the enclosure identifier as the serial number. All right, the third disk that we're going to redo again is the NVMe SSD. And so using Device Manager, looking at the parent property, it reports it as MSFT300123456799907. And so in this case, it appears that the Device Manager only sees the enclosure serial number. And if we use the Wiebetech write blocking utility, it reports 21234S801548. So this utility picked out the correct serial number. And lastly, with FTK Imager, if we load in this particular physical drive, we get a serial number which is a whole bunch of zeros, which is not so useful. All right, so after running these tools, I'm going to give a revised assessment of Windows with respect to the tested SSDs and enclosures. Using the Wiebetech write blocking validator, you're actually able to get some variant of the real serial number. So with the right tools, maybe Windows isn't that bad after all. For more videos on Windows forensics, see these videos here. For more videos on the Linux command line, make sure you watch these videos here. Make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.